So what are we going to talk about today? Let me give you the rundown of the basics of how we're going to do it. We have the lesson slides. That's what these are. And if you go to the this New Orleans stat training page, clicking on this link slides will bring those up. Also, if you click on this full text version link, you'll get a more beautifully flowing prose describing the same information that's on the slides, which you can follow through on your own. It's all the stuff we're going to be talking about. Again, if you're doing this on your own machine, you'll click on this worksheet to get the script file. But if you're on Posit Cloud, here's how you'll get the worksheet that we're going to do right now. So everybody can go and click on day 1 folder to open it up. And then lesson 1 worksheet.r is the R script worksheet for this lesson. So click on that. And a text file, basically an R script file, will open up. That's code, but the code is incomplete. In a lot of places, it will have 3 periods and just to fill in the blanks. So once we get to the code, you'll have to edit this by deleting the blanks and replacing it with the code. And I like to do this because if I gave you no code, you would have to type everything from scratch and you'd fall behind trying to type everything. And if I gave you all the code, you need to get that muscle memory in your fingers of actually typing it to be able to learn it. So this gives a good compromise because you have to type some, but if you fall behind, also if you really fall behind, you may you can go to this text version and copy and paste anything you missed. Just copy and paste. Any questions on that logistical stuff? Great. And I want to just give you your learning objectives so you'll know what you're supposed to learn or what you're going to learn. We're going to learn what R is, what you can use it for. We're going to use the R console, the terminal you just saw on Posit Cloud or on your own R Studio to do some R commands and make the computer do things using R. To learn about the data types, the most common data types in R. Since R is a statistical programming language, we're going to learn a little bit about how statistical distributions work in R. And finally, we're going to learn about what R packages are and how to install and load them. Those are our learning objectives. So what is R and what is R Studio? Well, since Posit Cloud is running R Studio, they are software tools to help you work with data. And the way that they work is that there's a base R, and then there are packages, which are collections of code that do a certain thing. And users may contribute packages to the main package repository of R. Like there's a package for, there's like packages for mixed models. There's packages for analysis of agricultural data, geospatial data packages for working with bioinformatics. Like they all have sort of different purposes, and individual users write that code and submit it. So it's sort of a crowdsourced model. And it's also free software that's open source. So you can look at any source code and all of this is freely available, which is nice. And R Studio is kind of a graphical interface that helps you write and run code in R. But R Studio is not R. It's basically an interface to R. You have to have R installed on whatever system you're using to use R Studio. It's just a way to help organize the code and its output in one place. So let's go, and we'll go back to the Posit Cloud R Studio window and look at what the different panes are. So when you first open R Studio, what are all those different sub panels on there? So yes, we've already seen this pane has the Files tab in it, which we can use to look at the file system and go through directories and open stuff. And it also has some other tabs, like once we start to make plots, you can switch to the Plots tab, and if a plot is made, it will come up there. We don't have any yet. Or help documentation is there as well. And This is the environment pane right here. And once we start to create variables and define variables, which are data objects, it will show you what ones we've made. Down here is the console, and that is where you will enter in individual commands, and R will run them one at a time. But the best way to, usually the way that I recommend coding in R is not to write code one line at a time and enter. It's to make a script, which is a text file that you can save and run again later. That's sort of the whole point of using a scripted programming language, is that you can save your thing and then with one click run the whole thing again exactly as you did before. You know, that's the advantage over a point and click tool like Excel to do data analysis. So if you open your scripts, open up here, they're .r, but it's basically just a text file with R code in it. Any questions so far? Yes. Yes, this is the worksheet. So again, if you start out in the home directory project and open the day one, and then you click on this lesson one worksheet.r, it will open this up. And this is the code we're going to be doing in the lesson today. We're going to be running through this code, but it's got blanks in it that we're going to fill in. You're responsible for typing in and filling. There's no grades. You cannot fail if you do it wrong. But if you want to get the most out of it, you should type and fill in the blanks with me. But I'll be doing it with you. No worries. No worries. Pleasure. Okay, so let me give you some of the basic data types. This is sort of like if you've done programming before, you know, if you've done C or anything like that, you'll probably know about data types. But if you haven't, this is going to be new to you. So please fire away with questions. Basically, in computer science, we have what's called variables or data structures. That's something that an object that has data in it. So like it could be a bunch of integers. We call that a vector. That would be kind of a list of numerical values is a vector. That could be one variable. And in R, the C function is how you create a vector. I'll talk about what functions are in a minute. A variable could be a single character string, like characters or text variables are in have quotes around them. So that's variable. Data frames, which are kind of like the main workhorse of R in terms of how data is stored. It's like a spreadsheet, essentially a tabular format with rows and columns. One entire one of those is a variable. That's what variables are. We'll go through, we'll meet a lot more variables as we go, if that doesn't make sense to you. And a function is another really important thing in computer science. R also has functions. Function is something that does something to your variables. It has input. A lot of times the input is called the arguments. It does something and then it gives you output, more new variables that the function created. So like log is a function in R. It takes the natural logarithm of, takes a number, comes back with another number, the log of that number. And you can see the functions always have a text name and then parentheses. The inputs of the function go in parentheses. So log parentheses 10 means take the input 10 and take the logarithm of that. C, a function I mentioned just now, stands for combine. That's a function used to create a vector. It takes multiple inputs and gives you a vector. And the way you give multiple inputs is you put commas in between them. 1, 5, 6. So what you're telling R is, say, I've got 3 values, 1, 5, and 6. Take them and give me a new value, which is a list, 1, 5, 6, basically. And functions can also work with data outside of R, like read.csv. Hopefully the names of the functions should tell you what they do. It's going to take a comma separated value, a spreadsheet file, and read it in. And the way you tell R what file to read is you give quotes. you can do single or double quotes whenever you make a character string. You have to give it the name of the file as a character string. So it's saying, take this character string, get the file that corresponds to that, import it into R into a data frame so I can work with that data. That's also a function. Yes, Marina. Yes. If you do not provide the file path, it will look first in the working directory. So whenever you run R, it's running out of a directory. That's called the working directory. If you don't give a path, it will look for it there. If it doesn't find it, it'll give you an error. So yes, but this is just an example, and we'll look at paths in a minute when we import data in. Actually, I don't think we do any of that in this first lesson, but in the second lesson we do. Okay, so let's go and actually write some code. And now, whenever okay, so I should mention this. When you write code in R, you can either well, I'll show you two different ways. Every time I go to the top, you can either hopefully you can see this way down in the corner. Maybe I can move these around. Well, can people see the bottom left-hand corner of the screen? So that's where, if you can type things in there. So like you can just use R as a calculator. Like if I want to do 2 plus 3, if I type 2 plus 3 down here and hit enter, it will give me the output right there, 5. And you can see it has a 1 before the 5. We'll say what that means in a minute. You can also see that you can write you can put spaces around the plus signs. You can always put some spaces in to make the code more readable. I usually do, but it does not affect the output. It's also 5. Another way you can write and enter code is, you can see here's the console. I have 2 plus 3 up here. If you type code in a script, and then if you have your cursor on a line, you can hit Control Enter, and it will run whatever code whatever line of code your cursor is on. It will run it. Control Enter. I did 2 plus 3 again without having to. So now I can save that code in my script to run again later. But if I want to just run one line, I hit Control Enter. Or if you want to run multiple lines at once, highlight or select an entire block of code, and then you can hit Control Enter and run that code all at once. Any questions? Okay, so yes, and you can do, obviously addition, subtraction, multiplication, division, exponentiation, all those basic operations you can do. Here's a more computer science-y thing that you have to be able to know how to do if you were working in R, which is the assignment operator, a way to create new variables. And this is the assignment operator. Looks like a little arrow pointing towards the left, right? It's got the less than sign and a hyphen, and you read that like you write the name of the variable, the assignment operator, and whatever the value will be. And you read the assignment operator gets, like variable gets the value of value. So like if you want to make, and variable names cannot contain spaces or start with a number, but they can have dots or underscores in them. And you might see code where people use the equal sign as the assignment operator, but for consistency, I'm not going to use that. I'm going to always use this arrow, just because it's always good to be consistent when you write code. It makes it easier for you to be able to diagnose problems with it and for other people to use it. So here's some different assignments. Let's say we want to take our 2 plus 3, and instead of just printing that output, we want to actually make a variable called X that we're going to use later with the result of that computation. So in place of these blanks here on line 13, we make our arrow less than and hyphen. So it says X gets 2 plus 3. In other words, take 2 and 3, add them together, the result, store it in a new variable called X. If I hit Control Enter, that will run, but you can see in the output, it does not say 5, because if you assign an output to a variable, it doesn't always print the output. It just saves it to a variable. Now you can actually look in your environment tab if you did this correctly. A new variable was created called x, and it has the value of 5. So now if you want to do more computations later with x, you've got it there to do it with. And if you want to make it print, you can just type x in the console and hit enter without doing anything, and it will print the result of that command, which is just to print x. And we can also, we don't have to do computations to create a new variable. You could just assign any value you want to a new variable. So y, and right, you can either use the equal sign, or you can use the assignment operator to assign y to a new value to y. So y, we'll do the equal sign here just to show you. Y gets 3.5. If you hit Control Enter now, the second variable is created, y, that's 3.5. Yes, so Hala. Well, if you try to print the value of x without first creating x, it will not work. So you need to run this. There's no space in between the two parts of the assignment operator. It's just, you can put spaces on either side of it. It will not affect the out. Like if you could do it without the spaces, it would work still. But I like to put spaces to make the code more readable. If you run this line and then print x, should work. Right. If you type x in the console and hit enter, it will say 5, hopefully. So we've gone to adding 2 plus 3. Let's see where else we can get in the next half hour. So yes, as I just said, entering the name of a variable, we just did that. And again, if you assign a value to a new variable, it will just be available for later use. So I have a few examples. Like now we have x and y. We could add x plus y, or we could, multiply x times 4, anything like that. So if you scroll down a bit, you could, I'll put my cursor on line 16 and hit Control Enter. X plus y, you can see the output is 8.5, but no new variable was created there, so it didn't make anything new. It didn't do anything and change x and y. It just did a computation to them. Yes. No, this is good. That's at the very top. So I think, yes, if you just scroll down, it looks like you went back to the top. So just scroll down some and you should get to where we're at. Let's see. No, it's good. Okay. Oh, you scroll all the way. You just scroll back over to the, it looks like you just went over. Oh, I see. It looks like you just deleted everything somehow. But that's cool. The best part is if you delete everything, it doesn't matter because it's only a computer. So I think the best way to do it, if you did that, is go ahead and go back here, click on that, and just make new project again. It'll just start everything. Yep. And yep, hit OK. Just start it all over. You can do that as many times as you want. But if you do delete everything, don't save the script. And I think somehow it looks like you saved it after you deleted everything. So yes, I'm not sure. But again, you can't really mess it up because it will, you just start it all over again. Yes. Well, yeah, I mean, yeah, you could probably, maybe if you undid a few times, but yes, you can just Control Z to undo, or in the top, there's like an edit menu, just like a word processor, you can go edit, undo. Yes, that might be easier too. Yeah, you see edit up there. If you if you, yeah, you got undo and redo and all that kind of stuff. Yes, this is nothing but a text file. It's just text. So you can work with it as you would any text. Undo, redo, cut, copy, paste, and so forth. Okay. Now you can manipulate, you can say x times 4. Again, you get 20 because x was 5 before. But we didn't change x. We just did a computation and output a result. You can actually do a computation and assign a value back to the same variable you did before. Like we can say x gets x plus 1. So if I ran x gets x plus 1, what will happen? Can anybody tell me? That's right. So x will take a computation, x plus 1, which is 6, and assign that result back to x. It will overwrite the 5 and turn it into a 6. Yes, so, and then if we did z gets x plus 4, after that, what will z be? Well, oh yeah, x times 4. So, but yes, I said plus, but times, yes. I was like, wait, that's, yes, it would be, well, it will, right, because x is not 5 anymore, it's now 6, so it'll be 24. So we'll do x gets x plus 1. We'll do z gets x plus 4. Yeah, you can see it in your environment pane. We got 6 and 24. You could also type in z, hit enter, and see it says 24. But if you ran this line 19 multiple times before you did the next line, x wouldn't be 6 anymore, but 7, 8, and so on. And you can see some of the lines have a pound sign or a hashtag, whatever you want to call it. Whether you call it pound or hashtag is determined by how old you are. You can put comments in your code that even if you highlight and run that, it will not evaluate anything, which is often useful to make notes explaining what the code does that you don't want to actually be run. If somebody were to run the entire thing, it would just skip over those lines. So like I put this whole header in as comments. If I highlight that whole thing and hit Control Enter, it kind of executes the lines, but nothing happens because anything beginning with a pound sign will not run. You could put a comment after some code on the same line, and it will still keep the first part of it, but anything after the comment sign is ignored. Now, we already mentioned once functions and input and output arguments. So let's try that. We can do log as a function we already discussed. It takes an argument of any numeric value and will return another numeric value. Sign is also one, and pi is a built-in variable in R that has a value of pi. So we can do on line 22 here, or if you typed in stuff, your line numbers will be different now, but log parentheses 1,000. Oh, and you see, if you start typing a function name, some help documentation will pop up showing functions that begin with the letters log and what their arguments are, and automatically bring up the help, which is pretty helpful. But you can hit escape and make that go away. But you can also scroll up and down, and it's useful for typing in code if you forget the names of functions. But now I type log 1,000 and hit Control Enter. And it is not log base 10, it is a natural logarithm by default. You can there is an argument for the base, or you can put log 10 if you want the log base 10. Sine, so yeah, your mathematical functions are all in there. If you do sine of pi, Control Enter, you can see, so this is interesting, it's 1.224 times 10 to the negative 16th. And that, well, first of all, you learn two things from that. Number one, R is using radians and not degrees for the sines and cosines. And second, that computers are not doing algebra necessarily. They are actually doing numerical methods to find arithmetic, to find the answers to these functions. So that's 1 times 10 to the negative 16, very close to 0. So actually, there's a little bit of rounding error in what the answers R is giving you. So that illustrates that. but it's very, very, very tiny. All computers are doing that, whether you know it or not. Yes. Sure. Yes, that's another useful coding aid that RStudio has, which shows you now. Oh yeah, that's a good point. If you open a parentheses, you have to have a corresponding close parentheses somewhere else in that line, or it will not run. So let's say I got rid of that last parentheses and I hit Control Enter and run. It says error, unexpected symbol in sign, because what it did was it skipped forward trying to find the end of the parentheses and made an error. So, I will, if you close the parentheses, it also even gives little warnings if a parentheses doesn't match as well. Yes. So yes, every time a parentheses open, one must close. And I mentioned this at one point, but I'll say it again. A function can take more than one input, more than one argument. And it will, if you do that, you have to put a comma. You can put spaces as well, but you have to put a comma in between each argument. So like, paste is a function, and paste takes multiple text variables, character strings, and pastes them into one long character string. So let's try that. Let's create a variable called my name, and I've given it gets the value of a quoted string, Quentin, paste, it should create one long string out of that. So you had to put quotes around it, double or single, it doesn't matter. But again, if you open the quotes, you have to close it with the same kind of quotes. So we hit Control Enter. Now we have a variable called my name. And if we say paste and give it two arguments, hello and my underscore name, hit Control Enter, it makes a new character string, hello Quentin, because we gave it two arguments. It's a trivial example, but many functions take multiple inputs and return the same output. Yes, the function paste has a default separated character, which is a space. You can actually add another argument. So yes, Thomas astutely noticed that hello, comma, Quentin has a space in between when the string is pasted together. Functions also have default arguments that are not, if you don't specify one, it will default to that. So the paste has another argument called set. If you give a named argument to a function, you would put an equal sign after it. So function arguments can have names, and that means this is a specific input that we're going to use for a specific purpose. So sep, that means separator. So if you put equals, whatever you want to put, you can put anything there. Now run it. You can see instead of separating with a space, it's separated with the new separator that I put. Yes, that's good observation. Okay. Getting help. Now that sep thing, great point, because what if you didn't know why the spacebar came up? Well, you could pull up the help documentation for the paste function, and it might tell you that. And the way you get help on a function is you put a question mark and the name of the function and hit enter in your console. So like here, I'll let y'all help each other. That's good. We want to see people helping each other. Are you all sorted out there, or you got it? Okay, great. So yes, if you hit control or question mark paste and hit enter, it will pull up in the help tab a help documentation, and you can see paste takes any number of arguments of strings you want to paste together. and then that argument sep by default is a space. So, and it tells you some documentation on that as well, what all the different, a character string to separate the terms. If you hit question mark paste and hit enter, it will pop up over here. So this is where the files tab is. The help will appear in the help tab there. If you don't see it, if you're switched to something else and you click on this help here, and it will pop up to the last help that you called. There is also, you can type 2 question marks and hit any search term. It will search the entire help documentation for a term, but I will say that I never use that because it's very slow, and Google is your friend and will pretty much give you a much better and quicker result. And I mean, nowadays, you know, people are using the language models like ChatGPT and other tools like that to help them code, which will give you even more targeted help. And certainly if you haven't done it before, haven't coded before, that could be a great way to get into it, and especially when you're learning and even beyond. So yeah, there's no reason to feel bad about that. Yeah, and I just mentioned already that when we enter some code in the console and hit enter, it will print the output to the console unless you assign that output to a variable, in which case it will not print, but the variable will be able to use later. But there's also some code, sometimes when you run code, it does not print to the console or create a variable. It does a side effect. Another type of output, like it might write a file, or it might create a plot. So the plot function is one that does that. This is the basic syntax to plot a y by x variable relationship, and the data input argument comes with some example data sets already with it. So this MT cars is data from like Motor Trend car magazine from a long time ago, different cars specs. So the miles per gallon on the y-axis by horsepower on the x-axis plot. So this isn't going to print out to the console, and is not going to create a variable. It's just going to make a plot that pops up when we run that code. Yes, that's right. That is like a by or versus the tilde. Any formula with y and x and r uses that squiggly. Yep. Go ahead, control enter on that. And you can see nothing, the code runs, it doesn't create a variable, and it doesn't print to the console, it just makes a plot pop up. So that's a classic example of one that has a side effect. And you can, in RStudio, you can save the plot to a file using export, but there also are commands that you can use to write images and data to files, which would be another type of side effect. Let's talk about some errors. We're already starting to see some of them crop up, but there are other there's other types of messages that you might see. Not all of them are errors. Everyone always freaks out when messages pop up, but some of them are just warnings or notes. So what are the difference between errors, warnings, and notes? Those are kind of the 3 main things you'll see. Well, errors are kind of like the worst one. They indicate that something went wrong and output is not produced when an error is printed. For example, here I have a parentheses that does not match. I have 1 open but 2 closed. And even this automatically highlights that to indicate there's a potential for an error. But let's say we ran that code, hit Control Enter. Error unexpected parentheses, because it's trying to parse that, but it can't. It does not produce any new variables and doesn't give any output, just an error. Okay? The next type of message is a warning. Now, let's say I take logarithm and give it -5 as input. We know that the domain of the logarithm function is only the positive numbers, so that's not going to work. If we hit Control Enter, it gives an output, which is NaN. That stands for not a number. And that is the value that is given when mathematically unsound numerical results are produced. But it still did it. And if you were running code, it would not make the code stop. But it gives a warning because it may indicate, maybe that -5 was the result of some other calculation you did, subtracting a baseline value, and then some of the values turn out negative when you take the log or something, and then you'd get a warning. The code still runs, but now you can't really, this NaN, if you try to add something to it later, it would still produce NaN because you can't, it's not a number. That's a warning. And yes, and lastly, there are also notes or messages that often pop up. They're just notes, like continue on with what you're doing because it's not an error or a warning, it's a note. Like ret is a function that means repeat the first argument value that many times and make a vector of all of it. So let's say it says repeat 0 100,000 times, make a really long vector. Usually you might want to do that if you're creating a variable. You might not usually want to print that to the console, but what if I did that? It will start to print, and the default is to only print the first 1,000. So then it says reached, get option, max print, omitted 99,000 entries, which is good because it didn't just start spewing out zeros. It stopped after a reasonable number of them. But again, it still ran and was fine. It just gave a little helpful note of how many values it did not print. Is everyone still with me? Okay. Yes, we're kind of moving somewhat slow, but I think this is important. So we can take a break before we get done with this lesson, and so at 2:30 we'll take a break regardless of where we're at. Yes, so far we've been seeing these ones in brackets. Like before the 5, there was a 1 in brackets. That is indication of a vector of length 1. So a vector, everything in R has some length, even if it's just one value, it's a vector of length 1. And a vector is a sequence of one or more elements of the same data type. So everything in a vector has to be the same. If you have any numeric, they're all numeric, or any character or text, always text. There's also factor and logical, which we'll talk about in a minute. And like when I did this rep command, you can see every line, it prints the index of the first element in that line. So like item 601 in this vector is 0, 602, 603, 604 is all 0, but it's a very, very long vector. And obviously, since data usually has a lot of data points, you might have a vector of data, each vector being an individual's measurement or whatever, they'd be in a vector. And then if you do one operation to a vector, you can do it to everything in the vector. Like if you wanted to multiply the vector by 2, you wouldn't have to multiply each item in it by 2. You just multiply the whole thing by 2. It'll multiply everything in it that way. So let's say we want to make a numeric vector. Here's a couple of simple ones. Let's say we wanted to make all the integers from 1 to 100. There's a function called seq. That stands for sequence, and it will make a sequence of counting up integer numbers. And they have named arguments. So again, like we saw already, if you name the argument, it's telling the function specifically what role that input will have. So seq has an argument from, to, and by. You put an equal after each one. From is where the sequence starts, to is where it ends, and by is how much we count up by each time. And that's one way you can do it. So if I left out some stuff for you there. So the name of the function is sequence. From equals 1, comma. Again, I put spaces in between everything where you don't necessarily have to. 2 equals 100, comma, by equals 1. Hit Control Enter. So yes, you might have accidentally auto-completed it with a longer function name, so make sure it just is seq. From equals 1, 2 equals 100, by equals 1. And feel free to play with this and change up the numbers however you want. Like if we did by equals 2, it will go 2, 4, 6, 8, and that kind of thing. You can, yeah, that's how you make an integer sequence. R also has a shortcut. If you just want to count up by ones, you can put 1:100, and it will count from 1 to 100 and make a vector. Control Enter. So that the two results are the same there. Yes. So those are vectors. And in general, the C function is how you make a vector of any arguments you want, in no matter if it's character, numeric, or whatever. You can make text values into a vector using, if you quote all the arguments, it'll create a character vector. A character is what the text variables are called. And so like if we, I just put A, comma B, comma C, comma D, 7 letters. If we use the C function, hit Control Enter, it will create that in one vector, which is 7 items long. I didn't assign it to a variable, but you could. R also has a built-in vector called letters, which is all the letters one at a time. And this shows you how you can index a vector, which means to pull out specific elements that you want. So here we have letters with 2 square brackets. And if we want to pull out specific letters, inside of those brackets, we will say the number values of which elements we want. So letters is a vector of 26 characters, A, B, C, D, all the way to Z. If we do letters 1:7, what will I get? A, B, C, D, E, F, G. Yes, Sohaila. They are not going to influence the results. It's just usually I do it out of force of habit. It's good practice to put spaces. Like this would work if you didn't have any spaces. Well, the error must come from something else. So the one place you can't put spaces would be like in the inside of a function name. You can't put a space there or anything. Yeah, you could put a space there, and you could put a lot of spaces there. It wouldn't make any difference. It would still work. So the error must come from something else. Let's see what we got going on. Who else is having an error? Yes. Equals 1. That's right. But every argument has to have an equal by its name. Yep. So by equals 1 indicates argument is called by and its value is 1. Now, if you hit Control Enter, it will give you. There you go. All right. Just a picky. Yes, that's right. It's not very forgiving. One bad period or whatever will ruin everything. So let's see. So we'll just finish this concept here, and then we'll take a break since it's about 2:30. Okay, so letters 1:7 will pull out item 1, 2, 3, 4, 5, 6, 7 from the letters vector and give you A, B, C, D, E, F, G. We could also pull out not consecutive. You could pull out any values from that vector, and so yeah, if you put letters and then give a vector of integers using the C function to create a vector, C1, 18, 19, it will give you the first, the 18th, and the 19th item of letters. 1, 18, 19. Control Enter. Yeah, so ARS will come up because those are the letters. See what I did there? Yes. Okay. So that's how you index a vector. That seems not very useful, just looking at it like this, but it's actually extremely useful because it's how you would take subsets of data and that kind of thing, or find data that matches a certain condition. All of that is done with indexing. So any type of analysis requires it. Yeah, so just to finish up talking about vectors, and then we'll break. The functions require a particular data type. Yes, Lauren. Yes. Yeah, yes, but R does support other character systems. If you like, yes, I can't say off the top of my head exactly how, but there are ways to get any type of character encoding you want. But the letters vector is just a built-in vector for convenience. You could define a character vector with anything you want, including like Unicode characters from other alphabets. Yeah, so functions require a certain data type. We've seen numeric and character so far. You get an error if you try to send the wrong data type as an input to a function that doesn't expect it. Log only takes numeric. You can't take the log of a character vector or a character string like hello. So you would that would give you an error, obviously. So Control Enter, and it says non-numeric argument to mathematical functions. So it's yes, that's pretty much just what it says. Another important thing to note is if you combine numeric and character in one vector, it will force them all to be character, because it's easier to turn 100 into a character you just put than it is to turn this text into a number, right? So often if you are importing data from a spreadsheet and instead of a blank cell it has missing value typed in, or something like that, M or whatever, it will turn that entire thing, that entire column, into character. So when you're importing data, you have to explicitly tell R which codes represent missing values in order for it to interpret the rest of them as numbers. So yeah, so that's just an example. If you hit Control Enter here, we have all numeric except for one character in it. You can see it creates, there are quotes around all that output because it's turned them all into character, because there was at least one character in it. Even if it was a million numbers, it would turn it into character if there was even one character in it. Yes, are there any questions? Yes. Yes, capital N, capital A. NA is the default for a missing value. Yes, so like I often get this where people will give me data that was exported from SAS and they'll have a dot or a period in it, which isn't the missing value character in R, so then it turns it all to character. But I just have to add an argument to my function that imports the data to say that the missing value is a dot, and then it will work. But yes, that happens a lot. And the same, I think if you were importing R data into SAS, it will, usually when you export data from R, it will just leave the missing cells blank entirely. No quotes around it, yes. So if we have C, 1, 5, 10, and just NA, it has to be capital, no quotes around it. We still have a numeric vector with a missing value in it, NA. Yep. Yeah, and if we, another thing I should mention is if you're typing in code in the console and you run a line, if you hit the up arrow, it will go back through the most recent code you entered. So you can go back through, use the up and down arrow to get back to the code without typing it again. So like if I multiplied this by 10, yeah, it'll multiply everything by 10, but it'll keep the NA is a missing value, so it'll stay missing. Any other questions? Let's take a break we'll break until 2:45, and I'm happy to take any questions during the break as well. So let's go ahead and get started again. My mic's on, right? People can hear that? Okay, cool. We'll keep going and try to knock this lesson out and see what we can get done of lesson 2, and see how we do in the next hour or so. I think most people are back, so we'll just get started again. Well, last time, right before break, we were talking about data types and how functions always require the appropriate data type to be able to get you the output that you expect. Let's talk about another couple of types of data that you can encounter in R. So we've seen numeric, pretty self-explanatory, and we've seen character, which is text. We also have what is called a factor. That's a very common data type in R. And a factor variable looks kind of like a character variable. It has quoted strings of text, but it can only contain predefined values. And since R is a statistical programming language, this was designed to be like levels of a treatment in a factorial experiment. That's why it's called factors. So the levels are, a factor variable can only have specific levels in it. Anything else will be invalid, and they are sorted in a specific order. So they are usually used for categorical variables in models like factors in an experiment. And if you fit a model with a factor variable as a predictor, it will automatically treat the first level as the control or the intercept in your model. So let's see, what does that look like? So to create a factor variable, we'll take a character vector using C, create a character vector, and we'll say low, low, medium, medium, high, high. So it'll be 6 elements long with 3 unique levels, low, medium, and high. And then we'll use the factor function to turn that into a factor. So we've nested 2 functions, first C to make a character vector, and then factor nested around it to turn that into a factor. And we're going to assign that to a variable called treatment. Let's say there's 2 replicates per level in this hypothetical study. We've got, then there's six experimental units. So I just did that to show that it has only 3 levels, but it has 6 values in it. Those would be like the replicates, 2 per group. Just for this example. So we, yes, the factor function and C to create that character variable. Hit Control Enter. Control Enter creates a factor with 3 levels. So yes, if you type in treatment into your console and hit Enter, it will give you. So here's the vector is low, low, medium, medium, high, high. You can see they're not in quotes anymore because now they are factors, not character, but the levels are high, low, medium, not low, medium, high. The order we put it in, it's sorted in alphabetical order by default. We've sorted it. That's how R does it by default. So if we made a model out of that, a model using this as a predictor, high would be the intercept or control group. That's the default is alphabetical order, but let's say we wanted to make low the intercept and have medium and high be the other groups. That would make a lot of sense if it's ordered low, medium, high, right? Even though that's not alphabetical order, we can sort the factor in whatever order we want by using the argument called levels to say what the order of the levels will be. So we want to take that old variable treatment and recreate a factor out of it, but now specifying the levels are this vector C, low, medium, high. So what order of levels we want, and that will sort it. So now it's low comes first in the factor level ordering. It will be like the intercept. Let's try that. So here on this line, factor is the function, and one of the arguments is called levels. Factor, so we're taking this variable treatment, creating a factor out of it again, but sorting the levels in the order that we want. and putting that result back into the vector called treatment, overwriting whatever was there before. Hit Control Enter on this line. Now, if you type treatment in the console, you can see low, medium, high are the levels in the ordering. It didn't change the order of the vector, it changed the order of the levels. There is also a reorder command. There's a relevel and reorder. There's a couple different ways to do it. One way is just to recreate it again as a factor. Yes. Yes, you could also, yes, if you like, I'll go off script here for a second. Relevel is a command to, if you want to relevel treatment and assign a new reference level, you can use the ref argument to make like medium the intercept if you wanted to. Relevel treatment, ref equals medium. Now medium is the intercept. That's another way to do it. Yes. Thank you for the question. Logical is another data type in R that's very important because it's what we use to do comparisons and do tests of on values. Logical has only two possible values. It can be either true or false. So a logical variable is a special data type that can only have two possible values, true and false, in capitals. You have to write, they're written in capital letters. And anytime you do a comparison, like a greater than, less than, is it equal to, you'll get a logical back because that comparison can either be true or false. These are the different logical operators you would use. You have to use the double equal sign to test whether x and y are equal. X equal y means are x and y equal. The not equal is exclamation point equal. Then you have greater than or equal to, less than or equal to. All of those will work to do a comparison and give you a logical. Here are some examples. So we're going to create a vector called x. X gets 1:5. And can anybody tell me what will x be once we do that? 1, 2, 3, 4, 5, because 1:5 means give me all whole numbers between 1 and 5 inclusive. So it's going to be 5 elements long. 1, 2, 3, 4, 5. Control Enter. It says an integer vector. Integer is a special numeric type, and 1, 2, 3, 4, 5. And we can ask, now if we say x is greater than 4, it's going to look at each element of x and each time test if it's greater than 4. Yes, so if we did that, we'll get, Control Enter on that. We get false, 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 true, because 5 is the only one that's greater than 4. It's a logical vector. We've compared each element to 4 and seen what one's greater. Yeah, so what are these? Yeah, we have less than or equal to. Okay, let's say I put x is less than or equal to 2. Yeah, if we put less than or equal to 2, can anybody tell me what it will say without doing it? All right, well, go ahead and just say it then. That's right, 2 trues, because 1 and 2 are less than or equal to 2, and 3 falses. Yes, you get the idea, right? And so I won't make you go through that for everything because it should be pretty obvious. X double equals 3 means which elements of x are exactly equal to 3. Control Enter, it's only going to be true for 3, everything else not. If we do x is not equal to 2, it will give us true for everything where it's not equal to 2. Say true, false, true, true, true. There are, you can do the AND operator, which is an ampersand, to test 2 comparisons together. So x is greater than 1 and x is less than 5. That's going to be only true for 2, 3, and 4 because they're greater than 1 and less than 5. There's an AND, ampersand. enter. So it gives you one logical vector for everything that satisfies both of those. False, true, 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 false. Okay, x is less than or equal to 1. And if we put the pipe operator in the upper right of your keyboard near the backspace, x is less than or equal to 1, or x is, or x is greater than or equal to 5. Control enter. It will give you true for 1. It is less than or equal to 1 or greater than or equal to 5, and 5 as well, but everything else not. So you can do and or. Those are comparisons of logical operators. And not will work to negate any comparison. You can use that. The exclamation point means not. So you can negate, turn all trues to false and turn all false to true. So instead, you can put a parentheses around any logical and flip them by putting not. So not x is equal to 3 will give you a false on 3 and a true everywhere else. Not x equal 3. Enter. It will give you false only on 3. They'll flip around the trues and falses. Seems pointless, but it's very important for any type of logic you're doing in data analysis. If you're doing different conditions on the data, you often have to do that. In is another operator. Parentheses in parentheses is a command, an operator that compares two vectors and looks at all the ones on the, it goes through the vector on the left-hand side and finds all the ones that appear anywhere in the right-hand side. So if, and gives true, otherwise false. So if x is 1, 2, 3, 4, 5, and we say the 1, 5, 6, 7, is that in x? It will be true for 1 and 5 because 1 and 5 appear in the vector 1, 2, 3, 4, 5. It'll be false for 6 and 7 because 6 and 7 do not appear in the vector 1, 2, 3, 4, 5. So we put parentheses in parentheses. Parentheses. It's hard to type and not look at the keyboard there. Okay, so if we look at 1, 5, 6, and 7, hit Control Enter. You can see 1 and 5 are true. 6 and 7 give you false because they are not part of the 1, 2, 3, 4, 5 vector x that we created before. If we do it the other way around, is x in 1, 5, 6, 7? What will it give us? Can anybody say without doing it? It's okay if you're wrong. First of all, how long will the answer be? It will be 5 because we're looking at the left-hand side, which is x, 1, 2, 3, 4, 5, and asking which ones of 1, 2, 3, 4, 5 appear in that one. Well, it's going to be true, false, 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 true, because 1 and 5 do, the others don't. So that's what we get. Again, that's often used if you're trying to subset your data by multiple groups at the same time. You would use in to get only certain groups and exclude the rest. What you usually use it for. Let's talk a little bit more about functions. We've got functions have different inputs. Some functions, we've looked at a lot of functions that work on single values. There's also functions that work on entire vectors at once. Some functions take a vector as input and return a vector of the same length. So like, for example, the exponential function, it will take a vector of numbers and raise it e to that power, take the exponential of every value. So if you give it 1,000 numbers, it will give you back 1,000 numbers. They're exponential of that. And here's some other, I'm starting to introduce more stuff at once to you here because now you are so good at this, you won't be overwhelmed by that. We will set seed means this is how you, if you're going to generate random numbers and you want to make sure they're the same every time for reproducible code, you set a random seed To initialize the random number generator, you can put any number here, 1, 2, 3, just anything you want to put. And if you run that same random number generator, again, it will give you the same result again. So that is useful for when you're doing simulations that have some random element and want to get the same one every time for reproducibility. And here's another function. R norm means generate random numbers from a normal distribution. And you can see it has some arguments, n, mean, and SD. N is how many random variables you want. So how long the vector will be, the mean of them, and their standard deviation. Mean of 0, standard deviation of 1. So let's set the random number generator seed using the function set.seed. And random underscore numbers is what we're going to call this vector of random numbers. We're going to use the rnorm function, and it's got 3 arguments. The n, how long it will be, how many random variable draws we want, mean of the normal distribution, 0, standard deviation, 1. Let's highlight all that and hit Control Enter. We'll run them all at once. So now we have a vector called random numbers that is a numeric vector with 1,000 elements. Yes. It's a so here let's you can see the first random number in this is negative 0.5605, right? Let's say I ran random numbers again without setting the random seed. Now it's some different number. But if I run it again with that same set seed, we get back to minus 0.5605 again, because it is setting the random is not truly random. It's a pseudo random generator. So if you set that seed to a certain anything, I could have put, you know, my birthday or whatever. If you put any number in that you want, it will, as long as you set the same seed, it will produce the same random variables. So now you all should also have the same one as I do if you set the seed right before you did that. And now here's a couple more functions. exp is the exponential of the random numbers. And notice I also put head around that. So we're taking the exponential of all the random numbers, and we're going to print the head means only print the first few numbers, so I can just see what is in this without printing the whole thing if it's very long. So we're head of the exponential of the random numbers. Control Enter. And now we have the exponential of those random numbers. So basically random variables from a log normal distribution, because it's the exponential of the random numbers. You should have the exact same numbers as me there if you did it with the same seed. And there are also functions that take a vector as input and just give you one summary value as output, one or a few. So like some of those very useful functions are length, that will give you the length of a vector. Mean will give you the mean of it if it's numeric. Median will give you the median, and SD will give you the standard deviation. So let's do that. Call all those functions on the random numbers vector and see what we get. Length of random numbers is 1,000. It has 1,000 elements. We can take the mean of it. Control Enter. You see the mean is roughly 0. It's close to the parameter was 0 was what we put, but because of sampling variation, it's not exactly 0, but it's close. And so what should the SD, if I call SD of random numbers, what will it be roughly? 1, yes, but not exactly, right? It's 0.99 because of sampling variation. And median also you can do. Should also be pretty close to 0 because normal distribution is symmetrical. It's pretty close to 0, but not quite. And there's also some other summary functions that don't always give you just one value. Range gives you the minimum and maximum of the vector as a vector of two values. If we do range of random numbers, it'll tell us the lowest and highest one that we got out of our 1,000 that we drew. So it goes from about positive to -3, which is about what you'd expect from a normal distribution. And another function is quantile. That'll give you the quantiles of the vector, but you have to give it another argument, probs. So which quantiles do you want? Probs. And that is, if we wanted the 2.5 and 97.5 percentile, as well as the median, the 50th percentile, we would say C 0.025, 0.5, and 0.975. So that'd be like sort of like the 95%, central 95%, and the median. So that's often summary numbers that you'd want. If you hit Control Enter there, it'll tell you the quantiles. Pretty slick, huh? Okay. Any questions? Yes. Yes, are you? Huh? Let's see, when you first started it. So if you, in set seed, if you put a comma or anything after without putting an argument, it might give an error. Yes, it is case sensitive, so it will not recognize SD capital letters as being the same thing as SD lowercase letters. You have to put it in the same capitalization as it has. Yes, that's R is case sensitive. Okay. No worries. Well, yes, so we've taken a normal distribution, so a bell curve with a mean of 0. A mean of 0 and a standard deviation of 1, a bell curve, right? Most of the values are pretty close to the mean, 0. And then as you go out on the bell curve, it becomes rarer and rarer. So if we take random numbers out of that bell curve, most of them are going to be real close to 0. Every now and then you get a really high positive, a really high negative one. That's how the normal distribution works. It's too bad there's not like a, well, I guess I could write stuff on that paper up there. I want to draw something. Yes, so it's R norm and not just norm. R norm means random numbers from a normal distribution. Yep. We'll talk about, I think I actually have a show a little bit more about the normal distribution in a second. Yes, so a perfect segue into the next topic, distributions. R is a statistical programming language, so it has statistical distributions built into it. And they all have different functions that give you information about that distribution. So like the normal distribution, the function R norm gives you random numbers from a normal distribution. The D norm gives you the probability density function, the bell curve of the normal distribution. P is cumulative density, which is very important if you're doing statistical hypothesis tests. But if you don't know what that is, I don't really have time to explain it now. And Q is the quantile of the distribution. Again, useful for statistical tests, but I'll illustrate. I think I have a slide illustrating. Yes, and again, so the normal distribution, R norm, always has the default of mean 0 and standard deviation 1. That's the standard normal, but you can change that by changing the mean and SD arguments every time. So yeah, what's D norm is basically it tells you what the value of the bell curve is at that point. So the standard normal at 0, its value is 0.399. So if you typed, you've already seen R norm. If you type, yes, I'll just do, just type it down here. D norm of 0 is 0. That's just the value of the bell curve at 0. Q norm tells you where you are on the x-axis if you are Q norm of 0.5 is where on the x-axis do you get to 50% of that normal distribution? If the mean's 0, the Q norm of 0.5 is 0 because half of it's below and half's above because it's a normal distribution. P norm is the opposite. P norm says if you are if you're at 0, how much of the distribution area is behind you? It's 0.5. And you can demonstrate that by typing in Q norm of 0.5 is 0. But like, let's say we change the mean of the normal distribution to 5. Q norm is 5. So at a normal distribution with a mean of 5 is centered at 5. 50% of it is below 5 and 50% is above. That's what quantile is of a normal distribution. Feel free to play with that on your own. So we can, in the interest of time, we'll move ahead. But we don't have to get into this now, but there are many other distributions you might use if you like stats, binomial, uniform, T. You may have heard of them in your stats class or has them. Basically, I just wanted to make that point. And here is something that maybe is a little bit more back to basics again. Here are some handy troubleshooting tips if you have errors in your code, many of which we've already seen here today. If you see errors, here are some of the first things to check. Let's check out those punctuation marks and make sure they're all balanced out. If you open a parentheses, you have to close it again. If you open a bracket or a quotation mark, you have to close it again. Like this, not going to work because it's got one opener and two closers. This has 1 and 1, so you're good. Spelling, if you start a variable and call it my underscore variable, later try to type in my variable without underscore, it will say error. We couldn't find my variable because you didn't use consistent the same name as you did before. So, and if you spell a function name wrong, it will also say it's not found. Spaces, we've hit upon this topic a lot. Spaces can be nice for making the code more readable. If you it'll spread things out, especially if you have very long lines of code. But you can't put all these were the same, will also give you the same results because they just have different spacing, but you can't put spaces in the middle of a variable name. That's the only place you can't really put spaces. And if you know Sass, you can type everything in uppercase, lowercase, a mix of the two. It won't matter. In R, that will not work. Sum is a function that gives you the sum of a vector, only in lowercase though. If you try to put uppercase, no, can't do it. So there's a tip. Most of the base functions are in lowercase letters for the most part. The last thing in this lesson 1 is packages, which I mentioned at the very beginning are user contributed chunks of code and functions that do a certain purpose. So far, we have only used the base R. We have not had to load any packages to do what we would need to do because we're just doing basic stuff. But almost all analyses that you would do in R require packages. And again, a package is a set of functions that an R user contributed that are available for download on a repository called CRAN. That is the R archive central. I don't even know what it stands for, but it's a website which has all the packages that when you download one, that's where you get it from. And if you want to use a package for the first time, you need to install that package. That means like you would install any software that you would use on your machine, you need to install it. So download it and get that code onto your machine so you can use it. Install.packages is what you'd use. And since we're USDA, there are, I believe, for the most part, by default, once you have RStudio installed, it will write any new packages you install to a folder that is not admin, that is writable by you. It doesn't require an administrator to come in and put their password in to install things. If somehow yours gets messed up so that it's not doing that, you need to get that switched so that then you can install packages without having to consult your admin. So let's install a package. There's a fun package called cow-say, which makes cow say things. So let's install the cow-say package. So install.packages is the function that installs a new package, and then you put the package name in quotes. So we hit Control Enter on this. And so it downloads a couple of files and installs them, gives you some messages. It doesn't say error, so everything's good. We've installed the package. But now let's say we want to use a function from the package. We only have to do this once. Now, every time you bring up this project again, or if you're on your own machine, every time you would open R again, the cow-say package would be there. You do not need to install it again. But it is in a sort of user directory. It's like usually in your documents/R. Yes, well, that's, yeah, so there's a lot of default ones that already come with R. But now you can see, yeah, cow-say is now there, yes. But the files are on like a sort of inside your documents folder, basically somewhere. Yep, and documents/R. And now every time we want to use the package, we need to load it. Yes. It will create one by default when you install R. It will. Usually it's your username/documents/R. Then there's like some subfolders in there where the packages go. Yep. It will put it there. Yep. Yep, it will. Yeah, no, go ahead. Yes, please. Okay. It has a default directory or set of directories where it looks for packages to check if they're installed. So if somebody gave it to you, yeah, I mean, people usually would have you download the package from the like R package library. They wouldn't really give you one necessarily. They could. You can install packages from files that people give you as well. So instead of, you would have to add another argument saying where the file is it's installing from. Then it's going to put that in that special package folder. Yeah, I think you could manually move it there. But, well, no, you really have to install it as well because it configures it when it installs it. Yes. Now we've gotten the package installed. We can load it using the library function, which means load this library of code or this package. We hit Control Enter on this. Now cow-say is loaded. We have to do that every time we use a function from the package. Just like you download software and have it on your machine, you have to open it if you want to use it. So that's like opening up the application. You load the package with library. So you have to run this install.packages cow-say first, and then you run this line and then this line. If you didn't install it and then try to do library, it will say not found. And then, yeah, so if you make a character string and then use the function say by equals cow, it will have a cow will say your sentence. So if you say USDA statisticians are the best, then you can make a cow say that, which is pretty awesome. There we go. And another thing to note is that this say function lives in the cow-say package. Sometimes there are multiple packages with the same function name. If you want to, you can be explicit and specify the name of the package followed by 2 colons followed by the name of the function. That will say, make sure that we use the say function from the cow-say package and not some other say function if there happens to be another one. And you also note that the by argument can take many values, like chicken could also be one. So you could have a chicken say hi. There's that, pretty cool. And remember, how would we how would we find out what other things can say stuff? What would we do? How would we find out what other values the by argument could take? Bingo. Yes. So if you type question mark say, there are yes, big cat, ant, pumpkin, ghost, spider, the list goes on. So you've got all kinds of stuff there. I think some of them are not safe for work, so I won't keep that on the screen for too much longer. But yes, that is how you would find help documentation. Yes. So and another thing to note is if you want to pull up the help documentation for all functions from a package, you could say help parentheses package equals the name of the package in quotes. Yeah, so you can say help help parentheses package equals quotes cow say, and it'll give you all the documentation. There aren't very many in that package. Yes. Yes, you can load. Right. Yes, you would load as many as you need. Usually, if I'm doing a script, I would load all the packages I'm going to need at the top, so that if any are not installed, you can just take that care of that right away. Yes, if you have multiple packages loaded, some of them might have overlapping function names because R is made by a bunch of different people and there's no real standardization for it. So that's why you might have to specify that. Yeah, that's kind of the end of the first lesson. I just wanted to end by mentioning the best practices of, I kind of made this before Chat GPT was a thing, but now that would probably also be a tool you could use. Obviously, the Stack Overflow.com is a question and answer site which has been answering our questions for many years and has a great fund of information. If you have a specific problem in R, odds are it's already been answered on there. And the Stack Exchange also has a stats. So Stack Overflow is where you have your more programming R questions. If you have a more stats question, stats.stackexchange.com is great. Recommended highly. And just other points about best practices. I think we've said this already, but in the console, where we type individual lines of code down here, that's great for exploring, but it's not good for if you have a complex data manipulation and analysis pipeline that you want to do multiple times and maybe have other people do. That's where you want to save those scripts and then you can run them again later or share them with others. And hey, we only went over a tiny bit of functions. You might have heard of lists. What about if, then, else, for, all that stuff? Well, those are really important, but we're not going to cover them here, and nor will we cover them in future lessons either, because there's just only so much time, and this, you could at least do, a semester to get into this stuff, if not longer. So this is only a jumping off point. I'm trying to give you enough tools so that you can learn how to learn the stuff in the future. But yeah, there's tons of other things out there that you might run into. Yes, so Hela.